This lesson we'll be doing nested for loops and nested lists. Before we do that, let's review or let's talk about something that I may have should have talked about last class, the aliasing versus cloning of a list. And then we'll do some list comprehension for nested lists. We'll do nested for loop to print out elements in a nested list, and then we'll do aliasing cloning for a matrix or multi-level container. So I plan on doing all of this in Python. So this first part in OneNote is just to sort of let you know what's going on. And then let's just go ahead and start. Now I've pre-arranged some things here in Python that'll sort of help me get going, so you don't have to sit here and watch me type in this long thing here. So so that's going to help us when we get down there. Anyway, so first let's talk about aliasing versus cloning. So let me give you just, I don't know, some arbitrary list here. So I'll tell you what, let me restart the kernel. I apologize, I probably should have done that first. So restarting the kernel gets rid of all of our variables. Press A, we got that little list there. And I'm going to set B equal to A. This is called aliasing. And let me show you why it's called aliasing. So if I printed A and B, if we print it, we get the same list twice. So, and that's what we expect right now. But if I went and changed out B0, and I said, so what is B0 again? B0 would be the 1000 that's right here. But what I want you to do is pay attention to sort of what's going on to this list right here. When I set B0 equal to -1, check out what happened. Because A and B, I just aliased B. In other words, I just sort of pointed B towards the same memory location that contains A. Think about for a second what's going to happen when I change B. B points to the same memory location that has this list in it. And so when I hit this button here, I think what should happen is these two should turn to -1. Let's find out. Okay, there you go. So you saw that they both turned to -1. And if I did the print A comma B again, we're going to see that they are in fact both -1. All right, so it's just printing out what's up there. So what's the fix to this? There's a couple of different things that you can do. The fix, for me anyway, is to slice. So let me just copy this again, Control C. I'm just going to copy this exact same list, and I'm going to say B is equal to A, and with the colon in there. And so what that's telling you is to slice through A, and this is called cloning. So now I'm cloning, I'm reproducing a new version of this list. So if I hit F9, so I just changed A, hit F9, and I just changed B. And now I go, so do the same thing. So B0 is equal to -1. You see only B changed, only the one that I told it to change changed. And that's because this is a clone, or B was a clone of A. So it wasn't pointing to the same memory location. It created a new version of it, if you will. Okay. Make sure that you understand that. So I'm going to go ahead and put a bunch of pound signs there. And now we want to create this list down here. So create a nested list. Nested lists. So this is nested list comprehension. And what do I need? Well, you can see, right? So if you go here, I see I don't have none in rows or in columns. I haven't really said what those are equal yet. So in rows, maybe that's 5, and in columns, oops, make sure pep8 in columns is equal to maybe 3, and run this. Oh, I haven't brought in my, here, I got to do it up top according to pep8. Import random as RAND. RAND is there, and now I can run the whole thing. And now I have some lists that I can mess around with. So you can come up here, you can see this one was the one that does a random integer between -9 and 9. So you can kind of see all the ones that came out for that run, and then this one just goes 1 through 15, right? So 1 through 3. So I just set this thing up so that it would give me a number corresponding to the number that's occurred so far. So you can kind of see the math that's involved in that inside that. So this nested list part here? So this would be a list comprehension inside a list comprehension. So that's what you're doing. So it's going to knock out the columns first, and then it's going to go down to the next row, and it's going to redo this whole thing for this next row, and then it's going to come down to the next row and redo the whole thing for the next row. And so that's the idea. It's like having two for loops, if you will. All right, so let's go m is equal to a, and the reason why I'm doing this is I want to set it up so I can do any matrix. So for I in range length of m. All right, so that's going to give me the index, the from 0 all the way up to n minus 1. However big length is. In this case, it's going to go the rows first, and then for j in range length, and I can't do m again, and I don't want to fix it at m0 or m whatever, so I'm going to do m of I. And so what that lets us do is if you have different number of columns on different rows, then this would still work. In other words, if you had 3 columns on row 1 and 6 columns, which is not true in mathematically, you can't have that. But in Python, you can have a list of lists that has 3 rows in the first column. 3 columns on the first row, 4 columns on the second row, 5 columns on the third row, and this would still work. So then we would want to do what? I don't know, print. Let's print f string. Remember how to do those. Position. So row column. The matrix has value. Now, how do we get the value out of that sucker? Right, because it's going to be m. Oops. It's going to be m, and then I got to go to the ith row in the jth column. That thing out. Let's see what happens. F9. You can see the 0, 0 is a 1, the 0, 1 is a 2, 0, 2 is a 3. So row column. And we can print this sucker up, or get this sucker up. So 0 row, column 1 is a 1, column 0 is a 1, column 1 is a 2, column 2 is a 3, or so on and so forth. I mean, if we didn't like the way it looked, let's see, I'm going to reproduce this, and I'm going to say instead of I and j, I'm going to add 1 to each one of them, because that's mathematically what we're used to seeing. So F9, and 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Okay, so that's the indices. These are the indices that we're used to seeing in those particular positions. All right, so that's a way to go through a matrix or a container of containers, a multi-level container, using a nested for loop. Now, I just want to make sure that you guys have seen this, because this is there's probably an easier way to do this using deep copy. So there's a library called copy, and you would have to import that sucker in and use this thing called deep copy, because the problem here is this doesn't work anymore. So let's try it. Let's try m is equal to a slice. So that's 9. So let me just run a control. So F9, F9. So we think we've just created a clone of that, but let's find out what happens. So print. As a matter of fact, let's just do the first one. So A00. So M 0, 0 should give us a 1, and A, 0, 0 should also give us a 1. And then when I set M, 0, 0 to negative 100, oops, forgot my equal sign, negative 100, check out what it does. So A is equal to negative 100 and M is equal to negative 100. So this didn't work. This was an alias. The way to fix that, and of course, if you left this off, it would be an alias. So I'm not even gonna worry about that particular version of it. So what you're gonna have to do if you want to not use deep copy. So there's an import copy module, and I've hit F9 right now. It would do it. I'm not particularly fond of that. So I mean, don't get me wrong, you're going to need that at some point. But right now, I can do list comprehension and accomplish the mission as well. So I'm going to let M. So we'll rerun A, F9. So F9. So A got fixed, and then M is equal to. So I'm going to list comprehend. Let's see, would be A, I, and then the colon, and then the slice, if you will, for I in range length. What is this thing doing? So this is now taking one row at a time and slicing it and assigning that equal to my matrix M. So it's going through one row at a time instead of whatever this does whenever it slices it. I think this does all the rows, so it's just not, doesn't work. So F9, and then I'm just going to copy these things, controls. So F9, 1, we get 1, and we change it, and then you can look up here and see that A did not change that time. And then I can just, and I can F9. This one's a negative 100, just like we see it up here, and this one's still a 1. So this creates a clone, is what we'll call it. Okay, that's all we got for this lesson. I believe that's all I wanted to do here. Yes, okay. Stop sharing and stop recording.